Life is weird. In all the years that scientists have been studying biology, they've come from estimates from 3 million to 100 million types of species on this planet. But how did life get here? One theory, called the theory of Panspermia, suggests that we came from some extreme aliens. What this idea basically means is that the seeds of life are passed throughout the universe, to different planets in the same solar system or to different planets with different stars. These seeds of life would be spores of microbes, and these microbes would be transported on asteroids or other types of space debris. We know in Earth's bombardment age that collisions of space rock hitting our planet brought materials and pushed more rock away from it, taking materials with it. What the theory of panspermia adds is that life in the form of resilient microbial spores could have hitched a ride on these colliding rocks and probably happened during a time when there were lots of collisions. Advocation for this theory can be traced as far back as the early Greeks, but it was never popular there. A few scientists have popped up in the recent centuries as well, showing their support, like Hermann von Helmholtz, a German physicist, and the same guy that absolute temperatures are named after, British physicist Lord Kelvin. For this to work, life would have to be pretty resilient, extreme. There are a group of organisms on Earth today called Extremophiles for their ability to survive what humans would feel like extreme conditions, but to them, normal everyday life. The suffix "phile" comes from the Greek root to love, and these organisms might not necessarily love the environment that they're in, but they definitely can tolerate it. For life to survive on flying masses in the empty vacuum of space, it'd be important for it to be able to cope with the extreme temperatures, lots of harmful radiation, and lack of water out there. The problem with really cold environments is that freezing of intracellular water that's in our cells, is lethal. You'd expect life to stop below 0 degrees Celsius, the freezing point of water, but the extremophiles called psychrophiles defy that. One psychrophile, called Panagrelamus davidi, can withstand freezing of all of its body water, and it's the only type of organism known to us that can do that. It's much warmer in here. Alright, besides cold temperatures, there's a problem with radiation, like damage to our nucleic acids, which are the building blocks of our DNA. Thankfully, extremophile level radiation doesn't occur on Earth naturally, but there are still some radiation-loving organisms on this Earth, like D. radiodurans, the organism that holds the record for being able to resist the most amount of radiation. The fact that there's not a lot of usable water when you're traveling in the vacuum of space is another problem for microbes. So for life to be able to survive desiccation and still maintain function with low water content in its cells would come in handy. You've probably already seen an organism do this though. When you bake bread, yeast has the ability to desiccate. It's been dormant in its packet even though it's just super dry in there. As cool as it sounds, the theory of panspermia isn't supported by mainstream science. I mean, it calls for whole cells to be transported on space rocks, and those space rocks to plant themselves on planets. So if we found life anywhere else in our solar system, that life, as suggested by the theory of panspermia, would be connected to the ones found in ours. So it is kind of hard for people to be unbiased towards. Plus, we have no direct evidence of life on meteorites, because so far as we know, anything crashing through Earth's atmosphere is met with a fiery entry, and this sterilizes the rock. Whether or not this theory holds true, extremophiles are being studied still. Some astrobiologists, scientists who are in the search for extraterrestrial life, are researching them. By researching the organisms that can live in extreme conditions, this widens the limits that we know that life can tolerate. And, in turn, this widens the kinds of environments that we could look into and probably find life. Like I said, life is weird.